So, how does one measure SoC accurately? Voltage method can be applied if you use the open circuit voltage, that means 0 current. So, generally when you use that, you use a current between C by 25 to C by 100, very slow rate of charging. Then you get nearly OCB and you use that as a curve which gives you the relationship. The question that I am asking is, what is the state of health? So, if it is a good battery, nearly 100%, we will get one OCB versus a SoC curve. If the battery is getting deteriorated, we will get another. This is not clear from the literature. In fact, this should be a important exercise that you should convey to Sushant. He himself should do enough experiments and do this measurement, and should be something get your data. SoC is a non-linear function of open circuit voltage, only in battery is fully at rest, very slow charge or discharge, not otherwise. So, the other method, what is the method therefore used in lithium ion battery? It is not the voltage method, it is a Coulomb counting. What is a Coulomb counting method? You count the number of coulombs that goes in. You start at a certain state of charge and then you start counting this much ampere current for so much time. You calculate the coulomb, and as you calculate the coulombs and coulomb as a percentage of total capacity, SoC keeps on going up. So, this is very important Coulomb counting, very accurate method, but dependent on accurate SoH and the precision of current measurement. Measuring the total current flowing in and out only gives you a change of SoC, it does not give you absolute value of SoC. And that is if state of health and the initial capacity is known. There also only it will give you change. So, the reference point is missing in the Coulomb counting. You have to assume that your initial reference point was okay. So, the very interesting method is used, that you use your initial reference point at any time with open circuit voltage and with the curves which have been already taken in the lab during the design of the battery. Use those curves, keep the battery at rest, no current going in and out. Now, measure the open circuit voltage. From that open circuit voltage, you measure the initial state of charge. That can be done. So, you know your initial state of charge. Now, you keep on looking at the coulombs coming in, and you can say, as the coulombs are coming in or going out, what is the state of charge? That itself will depend on state of health, and I will come to do. Coulomb counting requires correct starting point. This is the point that I am making. Correct starting point is very important. Now, normally what happens, if it is a fully charged, sometimes you charge it fully. So, you know it is a fully charged, it is close to 100%. That is a time you can actually then say this is a counting down, as this is a discharge, you can count it correctly. Coulomb count between two instants will give you a good measure of energy added or removed from battery, but will represent SoC only to the extent that initial SoC was good. Now, this is important. So, delta SoC, change in SoC, is charge pumped in and out of the battery, divided by the current capacity of the battery. Now, current capacity of the battery is the initial capacity, this is the initial capacity into SoH, this is the initial capacity. So, suppose you have taken 1 kilowatt hour or 10 kilowatt hour battery, and if it is a new battery, SoH is 1. So, charge pumped in and out of the battery divided by 10 kilowatt hour, you convert the charge into into again energy by and that will give you the change, that will give you change in state of charge, change in state of charge. If the battery is not new, you have to know what the state of health of the battery is. Suppose the battery state of health of the battery was 90%, then you say 0.9 into initial capacity, take the charge pumped in and out, and that will give you the actual delta SoC. So, this need to be converted to percentage, where charge pumped in and out is Coulomb count multiplied by electron charge E 1.6 into 10⁻⁹ or integration of current over time. That is a Coulomb count. Coulomb count is the integration of current over time. If computed charge is ion, the delta SO is positive, else it is negative. If computer charge comes as in or out, if it is in, delta SOC is positive, that means it is getting charged, SOC will increase. If it is out, then it is negative. So, SOC new is equal to SOC old plus delta SOC, that is a result that we have. Now, this delta SOC depends on SOH. Of course, you know the initial capacity plus you need to know SOH. The question is therefore, how do you know what is the SOH? I have been using the battery for last 3 months. How much has SOH gone down? With repeated charging and discharging, what happens? This delta SOC is a little problematic. You may make small errors and the error will keep building up. Now, error keep building up if you are careless and keep on using this formula again and again, your SOC new may be very different than actual SOC. I have seen the battery was charged 60% and battery was showing nearly 0 SOC. Why? Because error kept on building up. And so, this method, because it was the initial, it depends on the initial value and SOH value, all of that are changing. So, you can use it for a short period of time. You have to reset and recalibrate the battery after that time. So, this is an involved process which a battery designer actually have to do using the BMS algorithm, and this is where most people do not design good batteries. In lead acid, this was not there. Now, the question is, if your SOC is wrong, how does it matter? Well, you know, when you are driving, it shows you how many miles left, how many kilometers to travel, how much battery is charged. That will be wrong, nothing else will happen. You can keep on charging, discharging. You estimate is wrong, means you do not know how much more kilometers to travel, and this is very critical in electric vehicles. If it shows that you can go 50 kilometer, but real you could go only 20 kilometer, you will get stuck somewhere. So, this is an important thing which creates a lot of problem at times. You often think that the problem is with the meter. Actually, there is no problem with the meter. The problem comes because the algorithms have not been implemented correctly in the battery, and this is very common. Not very difficult in the beginning, because in the beginning SOH is clear close to 1. So, your result will not be that bad. As SOH starts falling, this error will keep on. So, the extent of error directly depends on error in current measurement and the degradation of SOH. So, delta SOC is okay, but both degradation in SOH as well as accuracy of the current. You are measuring only so many 0.01 ampere. So, to that extent you will be piling up the error, and if it happens to just sometimes it just cancels out, sometimes it just keeps on building on one side. So, what do you do? Well, you periodically recalibrate. You again take the battery to full and take that as SoC 100, or take it to absolutely 0, take it to SoC 0, and then restart, because it is the increment there. So, what I am pointing out, two problems with a lithium ion battery, and this is the reason BMS becomes very, very important. First problem is no really linear relationship between voltage and state of charge. Problem number 2 is that not just no linear relationship, but to the extent that you know the relationship between state of charge and voltage, it is only when the current is 0, open circuit voltage. In reality, open circuit voltage is not there. Open circuit voltage is there if your battery is not being used, no current is. So, therefore, voltage versus SoC is a bad method. Voltage changes with the rate of charge discharge, and changes during charging and discharging. A battery which is 100% full, you start discharging it immediately. If you see, immediately your this curve is very important, it starts fall. You start discharging at 2.5 C and your voltage immediately falls. Now, you take this voltage and you try to estimate SoC, you will be totally wrong. Similarly, during charging, you depending on the current, it significantly changes, very significantly. You look at this point, this point says that SoC is nearly 100, this is or different SoC, you can do it like this, same voltage 4 volt, here SoC will be nearly 0. In this case, SoC will be quite close to 85-90%, 80%. So, voltage versus SoC cannot be blindly used, and yet that is a very important parameter. The problem number 3 that you have, there is another method called Coulomb count, which is more accurate, but Coulomb count only tells you if you knew what the SoC was, I will tell you what is SoC now. So, your initial estimate still depends on the voltage and with all the complication. Now, even the delta SoC that you calculate depends on how accurately you know state of health and how accurately you have done the measurement. So, that itself the error keeps building up. So, it becomes very complex. So, how do you estimate the cycle lifetime remaining in a battery? That is what state of health is, referred to as a state of health. How do you estimate that correctly? Well, the best way is take a battery, completely discharge it, and discharge it at a very low current, in the end at least, completely discharge. When you completely discharge it and track open circuit voltage, when the cells have become close to 3.0 volt, battery is nearly completely discharged, that is close to 0%, 1% SoC. So, that is what you get one way. Sometimes you completely charge it also, and you have to worry about, remember that we had talked to you about depth of discharge, that battery is never fully charged, battery is never fully discharged. So, what are you talking about? So, there is a mechanism during the determining the state of health, you have to override that and you have to actually almost fully discharge. The lower percentage you will otherwise not go below, let us say 5%, but at this time you may have to go or you may have to fully charge, but otherwise it can be 5% to 90%, and we think 90% is fully charged. So, if you are starting with 5 to 10% error, you can get into total problem. After discharging, then you charge slowly. Slowly is very important, and carry out the Coulomb count. Give some rest, say several hours, at least I will say half an hour, and then you start charge slowly. That you do the Coulomb count, and that will give you the estimate of state of health. This is the total capacity. This is the total from totally empty to totally full. This is what I have measured. At that time, it will give you a state of health, and you use that state of health then again. So, indicates maximum charge that the battery can hold. What was the initially when it was new, what was the charge that it hold, compare it with past data, gives an estimate on SoH. There is an alternate method, but it depends on cell to cell. The internal resistance of the battery itself sometimes is a function of battery life. Not that depends on cell to cell, but if you can do that and measure internal resistance, that is easier to measure, you can measure state of health. So, point that I am making is state of health determination, state of charge determination is crucial to use in a lithium ion battery, not as important in lead acid battery, and that is the reason you require a BMS to do that. There is a self discharge of battery. When the battery is on shelf, it is slowly leaking. How much does it leak? If I look at lithium ion battery, will it leak 5% in 24 hours? That is the first time when you use it, it does that, but after that 1 to 2% per month, that is a typical. So, the battery, once you keep it charged, it will stay for 10, 50, even 1 month, it will be 1 or 2% less. If on the other hand I look at some others, nickel based, it is 10 to 15% 24 hours, and then 10 to 15% per month. So, this is much worse. Lead acid 5% per month. So, primary lithium ion 10% in 5 years. So, there are some good batteries. The self leakage is important, self discharge is important, and you do not want more than 1 or 2% in a month. So, that is a point that I was making. If test result shows that there is a 30% self discharge per month, batteries, discard the battery. But something is going wrong, it is self discharging. To sum up, understanding how much charge is remaining in the vehicle battery will depend on accurate estimation of SoC, and accurate vehicle usually display the kilometers that you still have to travel. You can travel, depends on the current SoC, and inaccurate display of kilometers that battery can support before charge would lead to a disaster from a user point of view. One day I was driving electric vehicle, I thought I had a decent SoC, it showed me about 35, 37 kilometer to travel. After a few minutes, I suddenly say it is 0% SoC. So, I did not know what to do. Should I drive? Should I stop? If I stop in the middle of the road, will it ever revive? What will I do? I kept on driving slowly. It kept on giving me warning that it is now 0% SoC. Fortunately, I could drive 3-4 kilometers, then put it onto a charger. When I put on a charger, for some time it remained 0%, and then it corrected and gave me 30-35%. So, it was actually not really 0%, but that is a mistake, that was delta SoC was wrongly calculated and gone for a toss. We can't let this kind of thing happen in a vehicle. and battery designers have to, therefore, the software people, the BMS hardware people have to really work hard to make sure that this works all right. This section kind of gave how to do it, overview. It did not give it accurately. Accurately, you still have to work quite a bit, get those curves from the measurement, etc., etc. And I am giving you assignment problem that battery has initial rated capacity of 10 kilowatt at 48 volts. Batteries are charged using a standard charging conditions. Coulomb counting indicates that 30 Ah has flown in before termination of charge. What will be a percentage SoC change when SoH is 90%, SoC is 85%. If SoH is 1% wrong, how much inaccuracy will you see in SoC? And then there are some true and false questions. Please try to answer them. The questions have been designed to really get you to understand the battery much better. There is another one which is a lithium ion cell when fully charged fully has an internal resistance of 20 milliohm. At its end of life, at the beginning of life, at end of life, the cell suffers a 150% rise in internal resistance. Determine the maximum peak instantaneous current that the cell can support at its beginning of life and end of life. Because 20 milliohms is the resistance. So, and it will become 30 milliohm. Based on that, you can actually estimate what is the peak current can it sustain, because if you put very large current, your voltage will go to 0, effective voltage is going to 0. Think of equivalent circuit, there is an open circuit and this is your load. Now, if the current I becomes high, all your voltage will virtually get eaten by the this itself. So, that is what you will have to use. Of course, the load is designed for certain current. So, suppose you want to try to draw for C. So, the load you can calculate, if I was 0, you can calculate what the load will be, and then you can see what will happen. A lithium ion cell at 3.65 volt, 15 ampere hour with 88% SoH is charged fully, and it is being used to power the load demanding continuous current of 1 C. How long can the cell power the load? It started with 88% SoH.